Yo, what's up, guys? I hope you are all doing well. Exciting time to be alive here. But we'll try to make the best of what we have, which is me on video. Yeah, that's unfortunate. Anyway, where we last left off was on chapter 7. You guys took a test on that. So that was on logarithms and exponential equations. So we're going to be moving on to chapter 8 today, which is all about rational equations, rational functions, which are functions that have a variable in the denominator. So we're going to be looking at those different components of rational functions, how to solve rational functions, graphing rational functions. But today we're going to start with inverse variation, which is very similar. If you remember earlier in the year, we did a lesson on direct variation. So not too difficult today. It gets a little bit more complicated later on in the chapter. But here we go. Let's start lesson 8.1. Okay, so lesson 8.1, we're going to be talking about inverse variation. So before we do that, I do want to recap what direct variation was. So let's go ahead and talk about direct variation. We went over this earlier in the year. Direct variation. Okay. And to say that, for example, y varies directly, okay, that's the key term, directly with x. Okay, to say that is to say that y equals, there's some constant of variation. We're multiplying when it comes to direct variation. So again, k is that constant of variation. A good example of direct variation would be, say, your total when you go to the gas station. So imagine y represents your total bill, and k is your price per gallon, and x represents the number of gallons that you purchase. So the total bill is very directly with, if x is, again, the number of gallons, your total bill is very directly with the number of gallons that you purchase. So what stays constant is the price per gallon. Well, it doesn't stay constant from day to day, but at least throughout the day, this constant, like right now, I think it's around $2. So this is staying the same. And what changes your total output is the number of gallons you purchase. So that would be an example of constant variation. Now, what we're going to be talking about today, inverse variation, then we're going to be doing some combined variations. So inverse variation. Let's say we have y equals, well, let me write it out in words first, to say that y varies inversely. Inversely with x. This is to say that there's an inverse relationship. So we have k, which remains that constant of variation, divided by x. Okay, so this is a little bit different. A good example for inverse variation would be, say, we're trying to paint a house, and the number of people that are on the job painting house, typically, if they're good workers, add to time, don't reduce the time. Sorry, reduce the time, don't add the time. The number of workers, let's say that's x, and y is the time it takes to paint a house. If we add to the number of workers, say normally for, let's say for one person, k would represent a full day to paint a house. Okay, the number of people we add to the job should divide into that full day, reducing the amount of time it takes. So that would be an example of inverse variation. Again, the amount of time it takes varies inversely with the number of people you have to paint the house. So the more people you have to paint the house, the less time it takes. Typically what happens with inverse and direct variation is if you increase x, okay, when in direct variation, that should increase your y, okay? If I increase the number of gallons I purchase at the gas station, that will increase my total. However, with inverse variation, it should do the opposite. If I increase the number of people on the job to paint the house, that should decrease your y, or decrease the amount of time it takes to paint the house. So that's basically direct and inverse variation. There's some different combined variations that I want to go over. I'm just going to take a picture of those just to keep the video time a little less long rather than writing these all down. Okay, here. So you can see a couple different things. Whenever you see this term jointly, okay, jointly, that means basically it's varying directly with x and y. So to say that z varies jointly with x and y, okay, we're saying that z equals, there's two things that are increasing z, okay? It's not just x, it's x and y that are going to increase your output or increase your z. There's also z varies jointly with x and y and inversely with w. So to say that it varies jointly with x and y are in the numerator. Inversely, when you see that word inverse, you should know that goes in the denominator. And then this says varies directly with x and inversely with the product of w and y. So inverses with the product, you know, is multiplication. So if it's inversely, it goes in the denominator. If it's directly, it goes in the numerator. And that's basically the sum of the lesson. If something varies directly, okay, you should be putting that in the numerator. If it varies inversely, that you should be putting your variables in the denominator. So let's go ahead and look at an example question involving this combined variation. Let's look at this. It's a word problem. Just taking a picture. I'm not going anywhere. One second. All right, let's look at this. Okay, so using combined variation, it says the number of bags of grass seed N needed to reseed a yard varies directly with the area to be seeded and inversely with the weight W of a bag of seed. If it takes 2 3-pound bags to seed an area of 3,600 feet squared, how many 3-pound bags will seed 9,000 feet squared? So let's go ahead and reread and pick out all the important information. It says the number of bags N, okay, number of bags N needed to reseed a yard varies directly. So when we see that varies directly, we should know if we're writing an equation, A needs to go in the numerator, okay, up top. Varies directly with A, and inversely with W, the bag. Okay, so our equation should look like this. Okay, we have K, and it said that's our constant of variation. A is varying directly and inversely with W, okay, which is the weight. So it says if it takes 2 3-pound bags to seed an area of 3,600 feet, okay, so 2 3-pound bags. So the number of bags is 2. Okay, that's represented by N here. We don't know the constant of variation. A represented, I believe, the area. Was that correct? A is the area needed to be seeded. So we know that's to seed 3,600 feet times 3,600. We divide that by the weight, which it said was 2 3-pound bags. Okay. So what we're doing here is using that equation to find our constant of variation. Once we find our constant of variation, we should be able to plug in 3-pound bags and then 9,000 feet in here to solve for our number of bags it would take. So let's go ahead and solve for K. Multiply both sides by 3. Should have K equal, or 6 equals K times 3,600. Dividing by 3,600. Okay, let's see what that is as a decimal. Let me grab a calculator. Well, it's going to be about, what's that, 1/600th? 6 over 3,600. That should be what? 1/600th, I believe. Okay, 1/600th. I don't know why I always use a calculator when I say the answer. 1/600th is my K. So If we are trying to find then how many 3-pound bags will seed 9,000 feet squared, we should have, looking for n, how many bags will seed, we have 1/600th times, what was the weight, or what was the area? 9,000. And it was 3-pound bags, so 3. So take 9,000 times 1/600th. Okay, that gives me 15. Divide that by 3 should give me an answer of 5. So since this is a word problem, make sure we have n equals 5 bags. Okay, that's the number of bags. Okay, and that's how we solve that one. Okay, so if at any point in the lesson you got lost, feel free to ask me a question, stop the video, rewind the video, do whatever you need. But that is inverse variation. I know it's a little awkward, at least for me. I don't know how you guys feel at home, but hopefully it'll get a little bit easier as we go through these. Hopefully I get a little bit better at doing these. Hopefully you guys get a little bit more used to them. But exciting stuff. Hope you guys enjoyed it. I'll talk to you next time.